Hey students, this is what we call a phase change diagram. Now, every substance would have a similar looking phase change diagram in which they have 3 lines at diagonals and then 2 lines that are horizontally across. When you're looking at the phase change diagram, you can see that the x-axis is going to represent an increasing amount of energy, and you'll see that the y-axis represents an increasing temperature. Now, looking at this phase change diagram, those diagonal lines represent the different phases. So which phase has the lowest amount of energy at the lowest possible temperature? Well, that's going to be your solids. The next diagonal is going to represent your liquids. And then which phase has the highest amount of energy at the highest possible temperature? That's going to be your gas. Now, those horizontal lines that are between the different phases, those represent the phase changes. So as you go from a solid to a liquid, we know that we are going to be melting. Conversely, when you go from a liquid to a solid, we're going to be freezing. Going from liquid to gas, that's going to be evaporation. And then from gas to a liquid is condensing. So knowing this phase change diagram could be very helpful in answering questions about intermolecular forces, about whether or not something is an endothermic or an exothermic process, things like that we're going to talk about later throughout this unit. Now, these horizontal lines, those phase changes, have a certain term that we use to refer to both of those, and that's going to be the heat of fusion and the heat of vaporization. So the heat of fusion, that's the area between the solid and the liquid, and that's referring to the energy that's required to melt 1 gram of a substance. At these phase changes, there's no temperature change. So there's energy that's being required to actually change the phase, but no temperature change is happening, okay? Now, the heat of vaporization, that's going to be the energy that's going to be needed to boil 1 gram of a substance, okay? So that's your phase change. Just make sure you're familiar with this. And I find it helpful to draw it when we talk about endothermic processes and exothermic processes here in a little bit.